This is Automata Design by Andrew Kapuros. Here's my social contract. So first we're going to define the problem. So in this project, basically what we were instructed to do is we're going to create gears, cams, and other functional pieces, put it all in a shoebox, and at the end it should be a 3D model of an automata. It should be a prototype of an automata, and we will be constructing a 3D model of it as well. Here's the rubric. This basically just breaks down what we will need to meet for each part of the slides that we will be presenting. And here's the design brief. This is basically, we got this from POTW, and this is basically just saying what exactly criterias we have to meet, what constraints there might be, how we might want to go by a certain pathway, and so on and so forth. Next, we have planning the solution. So first we have to create sketches, obviously. So these are some sketches of some ideas that I would have. So here you can see, this is kind of supposed to be a projector with a dinosaur. This is supposed to be bird flying in the clouds. You have a moon and a sun, and you have a rocket going into a town. So after I drew all of these, I went through the decision matrix and just said, out of these 5 criterias I have made myself, which one would meet all the criterias the best? And as you can see here, the one that reached the highest score was sketch number 1, which was the dinosaur one. So then I went back to sketch more in detail sketches of what it would look like. So here you can see the cams, and how I think the whole construction would look like right here. As you can see in the front view, you have the cams, you have the foot, and it's all pieced together. Here are my 3D models. These are my cams. So for me, I decided to go with a heart and a circle-shaped cam. Really, it didn't really matter for what I was making. I just thought these were a little bit more simplistic and better for me time-wise. Here are the measurements of these cams. Here are the multi-views. And here are different cam motions. This is just here to show you exactly what it would look like if for my cams to work when in the box. So here you can see the circle, you can see the heart. Circle kind of just goes normal up and down movement, while heart is more jagged. I was going to use the heart for the dinosaur, while the circle was going to be used for the projector. Here are some extra parts that will be needed. You have the hand crank, you have the foot. These are also, the foot will be connected to the cams, as that's the piece that will be going up and down. And obviously you need the hand crank to move the cams. Here's an annotated view of it all pieced together. The measurements shown here are not the measurements I went with. They're not the measurements that are on the sketches. These are just a dumbed down version of the measurements, so that I didn't have to draw such a big shape. Here are some possible materials that I could be using. You have wood, sticks, cardboard box, which is the shoe box, a knife, tape, rubber. You could also be scissors, some other stuff. Here's the Gantt chart. This is just me mapping out what I did on what days. You can see there's the define problem, there's the planning, there's the create and test, there's the evaluate. this is kind of just me mapping out what I did on what day so that I can look back and see, or other people can look back and kind of just see my process of making this. Next, we have create and test. So here's a notebook sketch of what it would look like. So I kind of just remade it now that I had the pieces. Here's the model itself. Here's the materials and tools I will be using. You can see there's the shoebox. I didn't go with cardboard, I went with foam. But there's also tape, scissors, the cams, and you can't see it here, but I also used water bottle caps, which you will see later. Here's the first prototype. It's very rough, but I mean, here you can see the cams. You can see what is supposed to be a foot. Very rough. And then here you have the hand crank. Separate parts. Here you see the hand crank. It's just a long wooden stick with a foam piece at the end. You can see the cams, and then here we have the foot, which is just a long wood stick with it's kind of this football goal shaped piece of foam taped to it. So challenges was in the first prototype. I struggled to getting the cam follower, which is the foot, to stay on the cam. The plan was for that shape to kind of act as a barrier around the cam, but it didn't really work. It really just pushed it away as you spun the cam instead of pushing it up. Next steps, obviously fix the foot, but I also wanted to continue fully building it. As you can see, it was very rough and it wasn't fully built. Now you have create and test, second iteration. Here's a notebook of what I think a better design would look like. So here you have what I was explaining before. We have the football goal shape, and then here you have kind of it flipped. So I thought maybe that would work. And so here you can see it. I just took a cap off of a water bottle and kind of just taped it to the bottom there. And then here you can see the difference. And here's it in work. It still didn't really work. What I'm thinking is that what was holding the foot in place wasn't allowing it to have proper movement. What it was supposed to do is make sure that it doesn't move around and it just moves up and down, but that didn't really end up happening. What I used for that was more water bottle caps, just with a hole in it, and it didn't really end up working. So moving on, I would think that choosing something different for that would be better. Challenges or changes, again, you can see the different in shape. Challenges, again, I struggled making the foot to stay on the cam. It would roll around instead of going up and down. But like I said, I think the issue was more of what was holding the foot instead of the foot itself. Next steps, I didn't have enough time to fully complete the automata, so I just ended up leaving it like that and going back and revisiting my slides just to make sure I documented everything. Now we have the evaluations. These are the people that evaluated me and what they had to say about my slides. After reading back on the evaluations, I kind of looked back and realized my presentation itself wasn't as good as it needed it to be. So I just went back and kind of planned out what I would say for each piece of the slides, just to make it more simple and fluid for me. So here's my evaluation of others. This one is of Austin, this one of Tristan. And then here is my self-evaluation. So what I would do better next time is I would make sure I planned out what I would do for the project better. I feel like I didn't give myself the proper time I needed to create both the automata and slides, which kind of made my model lackluster, as you can see. So next time I would plan out my time better at the start so that I had full time to do everything I needed. And we get to present. Thanks for watching.